Good afternoon, everyone. I brought this prop in part because I, like Mark, tend to talk a lot. And the only way I can assure myself of actually keeping what can easily be an hour talk down to 20 minutes is to follow these notes, so if you'll bear with me. The second reason I'm using this prop is I heard somebody else earlier talk about that unique skill set that we have, with people that are doing this stuff that are very, very good at high-performance computing, finance, and most of the work was actually done on this. It's an old X220 tablet. It's about 7 years old. And the wonderful thing about working with the RavenPack dataset is I don't have to worry about the the natural language processing components. I got a terabyte of data that I can quickly distill down using some very traditional bash, awk, sed, cut methods that you Linux heads would be familiar with. And then most of that actually then starts to work on this machine. So that's part of the reason I have it here as well. So let's get started. The graph. So a well-known member of the investment community, a member of the London Quant Group, is very fond of talking about this, calling it the graph, the reason Bob Shiller probably has a Nobel Prize. And so what you see here is the perfect foresight model of dividends. So their discounted present value is that slowly evolving line. And the other line is the real prices for the market index. And you can see just how different in volatility those two series are. But it's not just our friend. Actually, really knowledgeable people, too, like John Cochrane, makes that very same point when he gave his article about the two reasons why Eugene Fama and Bob Shiller got their awards. So to what do we attribute all of that variation? Now, if you talk, this is actually also interesting because at that time, when this thing came out, most academics were really focused on making sense of rational asset pricing. Okay? And this graph was a powerful counter-argument in just one image to that. Right? So why is this happening? Well, Eugene Fama came back and said, well, this time variation is due to risk aversion, which is tied to business cycles. Prices are low in bad times when most people cannot afford to take risk, and prices go up in good times. But what Shiller said was actually it's much more than that. We're not rational investors, we're bounded rational. And when that's true, irrational sentiments are what's driving market participants. Okay? So which of these two is it? And that's what I'm going to try to talk about. Now, I know that I've got 20 minutes, and I started with this long diatribe about why two camps in finance are doing what they're doing. But you gotta go with me a little bit early, because what's really important is to get the story as to why we look at sentiment from the perspective of a longer-run investor. You're not going to remember any of the numbers in this chart. I'll run through them. They're good numbers, okay? But what I want you to take away is the argument. So while much of the literature talks about really short horizon, HFT, and a lot of what the earlier speakers were saying, particularly what Richard was saying, rings true. I believe the speaker from JP Morgan was also talking about how news influences reversals. I think a lot of what was going on in the HFT space has been simple arbitrage trades when there isn't any new information. And when new information arrives in the form of news, people take those trades off. So it's really valuable at short horizons. But how do we make sense of it in the horizons of longer horizon investors? Now, I want to focus on something very, very narrow, okay? What I want to talk about is what I'll call sentiment regimes and how they affect the distribution of factor returns, okay? And one of the questions we'll ask is if it's actually driven by macro information and business cycles, the way Eugene Fama suggested is. We also want to know, there's literature going back to Baker and Wigler, and we want to know if this is actually distinct from that kind of a signal. And finally, we want to know if we can make money with this. And that requires finding a low-cost implementation which will rebalance on a quarterly basis. Okay? So that's where we're going to go. All right, so nothing too surprising here. We use style research data because it allows for a consistent implementation with their long history of factor performance. The data that we're using is just the usual suspects. And we credit RavenPack for allowing us to condense all of that information that they convert using their methodology into a terabyte of data going back to 2000. Right? So everything's done in dollars. We rebalance every year to get the 3,000 largest names globally. And we have something like 7,500 firms, close to 4,500 days of data going back all that time. Okay. So this is the RavenPack data set. Millisecond timestamps with a whole host of identifiers and metadata tagging. For me, going back to 2000 across all regions, that was about 1 terabyte's worth of data. And then what I did using Bash and some standard Linux scripts is to take all that information, bin it down into 5-minute increments, take account of positive and negative stories. By the way, we did the 5-minute binning because there's work by Kevin Shepard, formerly at Oxford Man. He's now, I think, in the Federal Reserve for a bit, that suggests 5 minutes is the gold standard for doing realized volatility. Okay? And to be conservative for the early history, we just assumed that we could not implement this any quicker than 5 minutes. So at the close of every day, we stop using that information 5 minutes before the close. And any information there is tacked on the next business day. Okay. On the bottom here, this was an email I sent to RavenPack to describe what it was that I was doing. That's a scene in Forrest Gump where the sergeant's got them scrubbing the floor. That's what a lot of data, this kind of work actually looks like. You're basically doing the unglamorous work of taking a toothbrush and scrubbing floors. But, the outcome is I'm taking this 5-minute data, replicating the methodology in a paper by Peter, where they take the ESS score and rank it as positive, negative, or undecided. If it's above 0.5, positive. If it's below minus 0.5, negative, and everything in between is undecided. Now, to reiterate, I incorporate daylight savings time by exchange, so I then add another tag, which is market hours and non-market hours. In their paper, they remove order imbalances in the US because there's so much of that. But my evidence was that it didn't really impact the positive and negative scores that were driving my signal, and for continuity with the other regions, I decided to leave that in. And so the last event of the day happens 5 minutes before the close, and this accounts for exchange time changes due to daylight savings. And this is just a graph of what the data looked like in North America. On the left-hand side, we've got a count of the number of stories by day, and then just a rolling average of that information. I believe that thing goes up to I can't see, 20,000, something like that, per day. One thing I did realize that it's very much dominated by the largest names in the US. So there's maybe 150, 200 names that account for 70% of the news stories. So when you start to construct measures like this, and you're thinking that you're going to look at this from an idiosyncratic stock-specific point of view, you have to be really careful how you do that. You might be able to roll these things up into sectors or industries, but aggregation is your friend with this kind of data. The next thing I wanted to note is just the seasonality in the data. So there's a very much a earnings season-driven seasonality to this data. So for that reason, Peter, and I agreed with Peter, do a moving average, which is quarterly on the information, right? So eventually, we aggregate it at the country level. We take the country data and then aggregate it into regions. We used Europe, Asia, North America. And what I'm showing you here is a decomposition of the time series of positive, minus negative divided by positive plus negative sentiment. So this thing can go anywhere between -1 and +1. What you see in red is a rolling 4-year moving average of that time series. And it's not, I think in the paper of Hafez and Xie, they didn't remove that. I'm just saying that along the length of time of half a business cycle, people are discounting that old information, so we include that and strip it out. The black signal is actually what we're using. It's the 63-day, business day rolling average. And when you take both of those out, what's left over is the daily surprise, which is what you see spiking up in blue there. Okay? So on the left is as close to the implementation of the original paper as I can get for the 3 regions. And on the right is what happens when I strip out the 4-year rolling average. And so part of the reason for that, too, was that I wanted to get a feel for the stuff that wasn't business cycle driven, wasn't macro driven, as the rationalists might argue. This was actually orthogonal to some of that business cycle stuff. The second thing is that if you look closely, you see a lot of periods throughout the entire interval go negative. So I didn't want the signal to be represented simply by the global financial crisis. I wanted other periods to sort of influence what we were calling positive and negative regime periods. Right. So is this thing actually business cycle driven or not? And so what I did is I downloaded from Professor Wigler's website his data, which comes in 2 forms. One is a raw form, which uses all of the signals that are beneath there, the dividend premium, the IPO volume, the first-day returns, closed-end fund discounts, and number of new issues. And when you combine all of those, you get the raw measure. When you orthogonalize that to macro variables, you get the first measure. And what you see is there's absolutely no correlation. Right? So we're not talking about Baker and Wigler measure. When we look at the decomposed pieces of the Baker and Wigler measure, same story. It is not that, with the exception of North America and new issues. So in North America, you got a correlation of about 12. Okay? So there's something about, in good times, the Americans like to issue new shares. When we then go over to looking at Fred data and look at some of the usual suspects, industrial production, consumer durables, non-durables, services, the NBR recession dates, non-farm payrolls, and the CPI, yeah, okay, there's now correlations in this data. But they're modest, on the order of 10% or to minus 10%. The CPI is very interesting because it doesn't matter what region you're in. Sentiment in any region is associated with the CPI. That's kind of cool. But you would expect something like this to be true. In other words, I don't really care as a practitioner whether what I'm looking at is sitting on the behavioral finance side of the equation or the rational asset pricing side of the equation. Some of that news is going to be driven by information in the macroeconomy, and it's good that it's getting into this signal, okay? So it's not the correlations overall, but they are, at least from a macroeconomic perspective, some of that is filtering in, okay? So now on to factor returns for the first time. What I do then is something very simple. I take the time series of factor returns by factors, and I have 4 time horizons that I look at. I look at 5, 10, 22, and 63-day horizons across 3 regions. So when I combine all that up, I get 132 different cuts of the data. Then I segment all of the return days into negative sentiment regime periods and the returns that came out of positive return sentiment periods, okay? And then I conduct what's known as the Kolmogorov-Smirnov difference in distributions test. And I was thinking, yeah, this is going to work. What I didn't expect is actually that I would get the results that I see. I did not, and I'm being hand on heart, I did not expect 131 out of the 132 to be significant. I certainly did not expect to get the everything in Europe everything in North America to be below the 5 in 10,000 level of significance. I didn't show any of the data because there's nothing to show. It's all just significant, 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 right? So this is actually more telling. Everything worked. That's pretty cool. Right. So that was an easy hurdle rate. A lot of things passed. I don't think I could make much of a meal out of something that works so well. So I tried something a little bit harder. And I then went on to look at what are known as monotonicity tests, right? So we actually care about the cross-section of factor of returns. That's what we really want, right? We want Q1 to return less than Q2, less than Q3, and so on, right? It's a far more stringent test. And there's recent literature by Patton and Timmerman that constructed these things, and that's been followed up by an improved version by Romano and Wolf, and that's what I implemented. Okay, so it's a much more stringent requirement to factors that they behave in this monotonic fashion. And for North America, so what we have here, let me see, did I get this right? Oh, yeah. So I have this tendency of doing all of these things automatically because I do so many presentations. So when I get things wrong, every slide's wrong. So when I say low, I mean small. When I say high, what I actually meant is large cap, and all still means all. It means the entire universe. So I've segmented it into the smaller half of the 3,000, the larger half of the 3,000, and then the entire universe. Then I run monotonicity tests on each of the factors across those 3 cuts of the data. Hopefully, the large universe is the liquid version, and you'd expect things to work better for, from limits to arbitrage arguments when you include the small space. Okay, so we do that, and there's something really cool. I mean, there's lots of zeros here, but look at for North America under negative sentiment, which is the stuff on the left. All right, if we are passing these monotonicity tests, the p-values are close to 0, and they don't look very great. On the left, let me see. They don't look very good under negative sentiment, which is the stuff on the left. And now again, I'm shocked. The next thing I'm going to show you shocked me as well. The stuff in the middle for large cap, okay? Almost across the board. No, not almost, across the board, geez. Across the board in the middle is what's happening to large cap. And when I only look at positive regime periods, what I'm finding is a very, very clean signal of monotonicity for any factor that I've looked at. I'm not used to seeing stuff like that, okay? So that was pretty cool. Like I said, you're not going to remember the numbers here, but you should be, I'm trying to impress upon you how unusual that is. I got 2 minutes? What slide am I on, 16? All right. So the same kind of stuff happens for Europe, for Asia. You're not going to remember the numbers here, but just remember that it's quite telling that you can do something this simple, just positive regime periods, and being able then to get a very, very clear view of how factor returns are behaving under positive sentiment. Very, very clean. Wait, when you said 2 minutes, did everybody then do an extra 5 or? All right, I'll try. It's cool stuff, and it's not the numbers you're going to remember, but the results. So we then say, all right, let's look at Sharpe and Sortino ratios for all of these across low, high, and all sentiment periods. On the left for the small cap, on the right for the large, okay? Oh, no, sorry, Sharpes are on the left, Sortinos are on the right. There's not that much to see here, except that there is a separation between what happens under negative sentiment, which I labeled low here, and high sentiment. In particular, for example, take a look at the top row, book to price, low, a Sortino of -0.76, which is highly significant, but under positive sentiment, a shine flip, and another very significant result of 0.62. So the spread between what you're seeing in terms of Sortino ratios is tremendous for these factors, or sometimes. North America, I won't belabor the point in the interest of time, but yeah, what I just told you rings true here. Individually, the numbers don't look great, but when you look at the spread between the Sortino ratios under low and positive sentiment, that really looks more dramatic. And Asia, remember, I skipped through the slide, but the monotonicity results for Asia were not good. And so you're not going to get water from a stone. The results here aren't that great, but that's really due to the fact that the stuff that I was hoping to see in monotonicity doesn't really show up that clearly in Asia. So yeah, all right. It works sometimes, but not worth going into. So the next thing I did was, I'm at 0, so give me 2 minutes. The next thing I did was decompose Sortino ratios into looking at returns, the numerator versus denominator. So I'm looking at returns and risks. So which of the two, when I decompose it, which of the two were interested? I'm using a very simple model. You can actually implement this in Excel, right? So this is not a methods paper. I got 2 dummies here. I've got a constant of all ones. I've got a dummy for the high sentiment regime, and I've got a dummy for high vol. And when I say high vol, I mean the top 80th percentile of historical volatility. Okay? So just a bunch of dummies. And I am looking at, on the left is small cap, large cap, and the entire universe here. And what I'm getting is nothing great. You wouldn't expect something that simple to actually work. Sometimes it does, actually. And what I find is that in small caps across the 3 regions, sometimes small cap, high sentiment results in low expected returns for small cap. Okay, that's North America, very similar. Asia, not much to speak of, not very similar. Now we're going to get to what happens in risk, all right? Pay attention. That is such a simple model. I can't believe with one constant, one dummy for high sentiment and another dummy for high volatility, pretty much everything is deeply significant and of the right sign, right? So the high vol is all positives, and it's telling you that it's persistent. The sentiment measure is negative, so that's telling you when sentiment is high, risk is falling. And since nothing really happened on the return side, it's all happening on the risk side. And it's Sortino ratios are improving because the downside risk associated with the factor is lower under high sentiment, and the returns aren't really being affected at all. Okay, same story, North America, similar results for Asia, with the simplest of models that you can do in Excel. Okay, goodness of fit, they're high. I'm getting, for this really simple model, I'm getting fits of between 40 and 60% on the risk, which is on the right-hand side. The returns on the left, whatever, it's not really that meaningful. That's true for all 3 regions. That's the result of redeploying the Hafez and Xie paper sentiment across regions on a daily basis. What we're finding is that it's very much associated with downside risk, and that's manifesting itself in the improvement of Sortino ratios. It also survives practical implementation. The results one would expect would be true for the entire universe of 3,000 names, that they'd be true for the smaller size assets, which are harder to trade, but they're very true for the large cap, which is wonderful. And we're rebalancing 63-day horizons, yeah, right? So these are horizons that are of interest to people that are doing TAA, plan sponsors, pension plans, people with large assets to move that might be thinking of implementing these things, but are not interested in getting risk on, risk off overnight. They want to hold these things for a while. We were able to show that with the use of data from Style Research, their factor data, people might think of incorporating this in a TA type of strategy. And we also, I think, reading between the lines, you'd see that the use of the RavenPack data allowed me to not think about the machine learning aspects of the problem, but to focus on the finance side of the equation, because that stuff was really easy to access. Thank you.
This is RavenPack.